It's Eytan Bakshy. He's going to be talking about designing and deploying online experiments with PlanOut. He's a researcher and a senior member of the Facebook data science team. He's been conducting field experiments at Facebook over 3 years, focusing on diffusion of information, behaviors, and networks. He also develops tools and methods for online experiments, including PlanOut, an open source toolkit for designing field experiments. And he holds a PhD in information from University of Michigan and a BS in mathematics from U of I. Thank you.
Thanks. I'm Eytan Bakshy. I'm a researcher on the data science team, or I guess it's now called the core data science team at Facebook. Some of the tutorial is going to be just me talking at you via a bunch of slides, but there'll be some portion that can be interactive. So if you just follow this link, it'll take you to this webpage where we suggest that you install IPython and PlanOut. So you just do sudo easy install PlanOut. And then you can check out PlanOut. So I'm going to go into my terminal and do a git clone. And we'll continue with the tutorial. So to consult a statistician after an experiment has been finished is often merely to ask him to conduct a post-mortem examination. He can say what the experiment died of. So oftentimes when people run experiments or A/B tests, it seems very straightforward, but oftentimes it isn't. There could be all kinds of errors in randomization and analysis, and it can be really dangerous to build your own tools. In fact, even if you have pretty good internal tools, it can be easy to make errors in your analysis. And so what I'm going to be talking about is a package that we developed that makes it easy and foolproof to run experiments. So the PlanOut package is a Python-based framework for designing and implementing experiments, and it promotes good statistical practice. And it mimics many of the key aspects of Facebook's internal experimentation stack. So the main component is PlanOut, which is this kind of language or system for assigning units to randomized parameterizations, and then a logging system and a management system. And all of these are just kind of generically called PlanOut, but as I talk, I'll be referring to PlanOut to mean more specifically this kind of assignment system. And so the outline for today is I'm going to talk about motivation, why run experiments, what kind of experiments do we run on the core data science team, why do I think this is exciting. And then I'll talk about the ideas behind PlanOut, and then dive into the tutorial where we'll be going through some IPython notebooks. So why run experiments? Well, the internet industry, experiments are very common. We often refer to them as A/B tests. They're most commonly used to deploy 2 ready-built versions of a website. So here's an example of the Facebook newsfeed in 2011, and through some gradual or some drastic redesigns, we now have the Facebook newsfeed as it looks on the right-hand side. But rather than rolling out just completely different versions, we might use experiments to just explore design space. So we might try to manipulate these little icons in the upper left-hand corner to get users to use certain features or to maintain a closer connection with their friends via messages. Or we might modify the search engine in some ways, or add some apps or promote pages, et cetera, in the left-hand column. Maybe we'll change particular story units. So in this way, experiments aren't just for evaluating 2 completely built alternatives, but to try to understand kind of what are possible changes, small changes that we can make to the website that can have impacts on user behavior. We can also use experiments to understand trade-offs in our design space. So here's an example of an experiment that we ran with Facebook Offers, which is a kind of way of distributing coupons via Facebook. And the default behavior of coupons was as soon as you redeemed a coupon, it would kind of share that information with all your friends, much like liking a page automatically shares this. And what we wanted to know is, what is the effect of doing this? We're potentially exposing users to users' friends to information that might be a little bit less relevant. So what happens if we instead add a share button? So this is a simple experiment that has a rather complex analysis and gets at a very deep question about peer effects in networks, right? How are your interests correlated with your friends' interests? And how does sharing have certain downstream consequences as to the relevance of users' behaviors? We can also use experiments to attribute outcomes to causes. So we have non-social ads which don't feature friends, and social ads which embed social cues alongside ads. So here's an example of a non-social ad and a social ad where we can see that my friend Gina likes the History Channel. And perhaps somehow this persuades me to like the page, but it could also be that because I have a friend who likes that page, they might be more similar to me. And so as a result, I might be more likely to click the page. So it doesn't really tell us anything about whether social ads cause users to click on the ads more or like more pages, but it tells us something about the kind of correlation between people's interests in social networks. So we could instead run a randomized experiment where we show either 0 friends, given that you have 1 liking friend, or 1 friend, given that you have 1 liking friend. And we could implement a lot of these very complex experiments that show any number of social cues with just a couple lines of PlanOut code. So those are some examples of experiments that we run that give us kind of deeper behavioral insights into our ecosystem rather than just testing 2 alternatives. And so far, these experiments seem pretty easy, right? We're just adding or removing a button, changing light gray text on a white background. But experiments can be really hard. There are all kinds of organizational problems that can occur. You have multiple teams running multiple experiments. You have a single team member running multiple experiments. How do you make sure those experiments don't collide in some way, or that your analysis interferes with somebody else's analysis? If you need to change something, how should you analyze these experiments? That's not entirely obvious. Even to a statistician, this isn't really clear. Furthermore, experimentation can be a mess. You can have experimental logic that's scattered across your entire code base, and it's really difficult to keep track of exactly what your experiment is, what the manipulation is. And then as a result, if you make any kind of change to your code base, it could potentially break your experiment. And this is really problematic as you start to scale up your company and you have many engineers working on your product. It also makes it difficult for analysts who might not necessarily be software engineers to understand the details of your experiment, which could be really dangerous. Furthermore, because your code is tied into the application logic, it also makes it difficult to run experiments on multiple platforms. So if you have an Android device and an iOS device and a server, and you kind of want the same experimental code to be executed on different versions of your platform, how can you make that possible? And so the solution that we came up with is this kind of domain-specific language and interpreter called PlanOut, which performs random assignments. And so in the PlanOut universe, you don't assign users to groups, to test groups. It's not user A belongs in group, user X belongs in group A or group B. There's a particular parameter that controls the website, like the width of the news feed, or the width of an image, or some font size, or how much padding we have. And that's some constant, and that can be manipulated in some way through random assignment. And so we've moved into this world from test groups to parameterizations of user experiences. And so PlanOut scripts are high-level descriptions of randomized parameterizations. And so the PlanOut idea is that user experiences are parameterized by experimental assignments, and PlanOut scripts describe an assignment procedure. So it's a very concise definition of how your experiment works. And an experiment is a PlanOut script plus a population. And parallel and follow-on experiments are centrally managed in some way and treated separately from one another. And so here is a sample PlanOut script in the PlanOut domain-specific language. And what this one script does is it chooses a button color with uniform probability and independently chooses button text with uniform probability. So this definition generates a 2x2 factorial design. Now this script then gets compiled into JSON, and we have this serialized definition that could be run on multiple platforms, shipped across the network, stored in a database, etc. The serialized code can also be executed in multiple languages. So I originally implemented PlanOut in PHP and maintained a parallel version in Python because I really wanted to keep it portable. I guess one day I woke up and PlanOut was written in Hack, which is pretty cool. And you could also imagine porting it to other platforms as well. You can also generate serialized PlanOut code via GUIs. So here's an example of a GUI we use at Facebook. And we'll be talking about how you might build kind of open source versions of this in our tutorial. And then our toolkit also allows you to express PlanOut in a Pythonic way. So here's an example of an experiment definition that implements very similar functionality. So this is the entire experiment, and then you're good to go with logging. So it's this easy. Yeah, and feel free to ask questions at any point in time. How do people feel about this font size? Oh, go ahead.
I have a question, sort of going back to what you said about compiling it to JSON and then distributing it across and whatnot. Is that specific to sort of the web development stack here at Facebook, the way you chose that approach?
Mm-hmm. The purpose for that is that we wanted to be able to have centrally managed experiment definitions that could be constructed via graphical interfaces or just looked at separately from analysts, or just so that people designing experiments don't even have to think about how it's implemented in PHP. And so that kind of separation from the application logic in the code is one of the main motivations for.
And I guess as a related subject, have you guys looked at other frameworks? I'm assuming you have before you built PlanOut, like Vanity, and why did you choose not to use them?
I actually don't know what Vanity is, but I would be happy to talk to you about it later. I mean, we have our own system that this plugs into, and we have a very large stack that we work with. And I think eventually you'll see what kinds of experiments PlanOut is capable of expressing. And I doubt that any other framework that other people have built can support the kind of experiments we want to run. Not to, yeah. OK, so we've got PlanOut here that's checked out. If we go to the contrib directory and the tutorial directory, we'll see a bunch of Python notebooks. We can launch the notebook by typing in IPython notebook. This is probably way too small for people. Do folks want me to make the font bigger? Yes? If I can see where the order is. OK, so I just basically copied and pasted this command that is both on this wiki and in the README and in the both locally and externally. So here's the getting started notebook. I'm going to toggle this stuff. So the first thing, is this font size okay for people? Cool. Yeah, the screen setup here is great. So most of your PlanOut experiments will import these random operators, which help you do the random assignment. And then as you're starting out, you're going to be using this simple experiment class. So this includes a bunch of built-in stuff for doing logging. And then for demonstration purposes, we're also going to use pandas. So we execute this. So this is our first experiment. This is going to be an experiment that runs on a new user sign-up form. And what we'd like to do is assign individual cookies to different button colors and button texts. And here it's just a 2x2 factorial, very similar to the other setup. And so to create a PlanOut experiment using the basic PlanOut framework, you define a class that inherits from simple experiment, and then you define an assign method. And it has one required argument, which is params, which is this kind of helper object for doing random assignment, and then some set of input units. So here it's cookie ID, it could be user ID. You could also pass in cookie ID day or something if you wanted to also do random assignment on the day of the week. The next line actually performs one of the random assignments, and the way that we do this is we say set attributes of this params object. So here we have an attribute which we're going to call button color, and we set it to this object called uniform choice, which picks among two choices with uniform probability using the input, the cookie ID, as the unit. And what PlanOut does underneath the hood is it does a bunch of hashing. So it says, OK, I'm setting an attribute of params, and this thing I'm setting it to is a random operator. So I'm going to execute that random operator, and I'm going to use the name of the variable that I'm setting and the unit and the name of the experiment and combine them together and then do a SHA-1 hash in order to assign that set of variables to a randomized condition. And this ensures that you get kind of a good random assignment and that your assignments are independent of one another. And so here we're setting two different factors. And the way that we use this is we create instances of this class to get an assignment. So here we have the cookie ID is 4. So we execute this. This basically gets a reference to the experiment once we request a parameter. We actually get the value. So here the button text is sign me up. So it's the second choice. If we were to change these, the randomizations would change. Also, underneath the hood, there's a bunch of logging that's occurring. So if I go to my PlanOut directory, there's a bunch of log data that's automatically being produced that I'll be discussing in a couple minutes. We could see a couple of randomizations for different cookie IDs. And if we're kind of skeptical that this stuff works correctly, we can just simulate a bunch of user IDs. What happens when we put a bunch of sequential user IDs through our random assignment system? We can generate this data frame. So this is one way of getting a data frame of random assignments. And then just tabulate stuff. And we can see that they're kind of approximately distributed 1/4 each. And like we could even make this number bigger. And the PlanOut framework includes a bunch of unit tests that actually do legit statistical tests to make sure all the random assignment operators work correctly. We can also do unequal probability assignment. So in this case, we have a second factor, which is chosen with a probability of 0.8 for join now and 0.2 for sign me up. So this could be like any kind of arbitrary integer or floating point value. And then we see that when we run this, things show up in the expected proportions. Are there any questions so far? Wait, sorry, I can't hear you.
We get exactly the same sizes, like 835, 795.
Yep. If you run this on your machine, it should be identical because PlanOut is deterministic. And that's the whole point. You don't have to store kind of what you've randomly assigned users to in some database and then go look it up, because you know for the given experiment definition and the given input units exactly what they're going to be hashed into. So everything is completely deterministic and platform independent. One advantage of this setup is that since it just uses SHA-1 and really simple hashing, it's easy to implement in other languages, whereas if we were to use some random number generator, we would have to like find ports of that same random number generator on different platforms, and that could get hairy. So here's another example of an experiment. So Google is famous for running this 51 different shades of blue experiment for their link colors. And if we wanted to implement this experiment, pre-PlanOut, maybe this would take an intern like a week to do, to code up each of these 41 conditions. Actually, hopefully they're a lot faster than that. We could instead write this really simple PlanOut script where we generate some random integer value, which is going to be our blue value, between 215 and 255. And that's going to be deterministic based on the user ID. And then we can just kind of insert this into a hexadecimal string. I guess this should be link color, but oh well. And you can see that when you do get params, we see the button color and the blue value. And we can run this for a whole bunch of users. It's computing. And now if we look at histogram of all the values, you can see that it's approximately uniform. And again, all of this stuff is unit tested. We could also do more complex experiments that involve assigning multiple units simultaneously. So let's say that we wanted to do a within subjects design where we are making a change to our ranking, our search ranking algorithm. And instead of assigning whole users to experimental conditions, which might have problems with statistical power if you think that each individual user has some individual level random effect or fixed effect, you can get better power by randomly assigning particular user session pairs to experimental conditions. So you can do this kind of within subjects comparison. And the way that we would do that is instead of passing in user ID as the unit, we pass in user session ID. So here our assign method just takes this additional argument. And instead of unit being a scalar, it's just this list. And we can see that as we mess around with this, we'll get different random assignments. We can also have randomized assignments depend on each other in some way, right? So PlanOut isn't just useful for doing factorial designs. So let's say that we had a team that had a series of related models that they were testing. Let's say they added some kind of features about what users' friends are doing into the ranking of search results. And we wanted to compare the control condition, which let's say is the current model, which we label V0, against 3 different versions of the model, 212, 213, and 214. And for each individual subject, we wanted to compare that baseline V0 against one of these experimental conditions. So what we could do is assign each user ID to one of these different new models. And then for each individual user session pair, we can randomly choose among these 2 options. So there's kind of like hierarchical or nested assignment. We can see for this user ID, they end up either in V0 or V212. If we were to change the user ID, so let's say 30, they're still assigned to 212. 31, they're assigned to V0 or 214. So what's going on underneath the hood? I kind of discussed this very briefly earlier, but the idea is that we construct this string, which is the name of the experiment, plus the parameter name, plus the input unit. So if you have an experiment that's called random example 1 and a variable that's called x, and the input unit, let's say the user ID is 4, to do the uniform choice, we might do something like SHA-1, take a couple digits of SHA-1 and mod it by 2. And that's how we're producing the random assignment. And so this middle component is the parameter level salt. And so what it uses as the salt, so the salt is just like some modification of the input string or integer that you're hashing on. In this case, when we set params.x, we're using x as the salt. So if we were to take this code and just say salt equals x, it's not going to change the assignments, right? Before A0, A was 494. If we nuke this, it would still be 494. Now if we changed salt of x to be x1, and not insert an extra comma, we would see that that number changes. But it's completely deterministic each time. Now, if we use the same salt for 2 different variables, the assignments would be correlated. So let's say that we use the salt x2 both for x and y. What do folks think is going to happen when we do the crosstab? Yeah, so these 2 variables are then going to be perfectly confounded. And so we're only going to have 2 unique values, right? Every time we pick 0, we're going to pick A. And every time we pick 1, we're going to pick B. So that's how parameter level salts work. There's also experimental salts. So experiment salts are also set automatically, and that's based off of the class name. So let's say that we had 2 experiments with essentially identical random assignment procedures. So in this case, random example 1 and random example 2, since they use the same variable name and are both doing uniform choice of 2 objects, just like an A and a B test, for this parameter, they should be producing some kind of correlated assignment if we don't do anything special. But if we run this, we find that the crosstabs are different. Because it's not just using the variable name, it's also using this experiment to do the salting. Now what we can do is manually set the salt. So if I were to say, if I were to define the setup function or method, which gets run before the experiment actually gets executed, and I said self.salt equals this string, now these 2 things are going to be perfectly correlated because we're using the exact same parameter names and the exact same salt and essentially the same kind of assignment. And you could imagine that in general, there are a lot of cases where you would use the same variable name. You might use the variable name button color, and you might be doing an A/B test, because in general, 50-50 splits are the best thing you can do in order to increase statistical power. An additional note / gotcha is that the order of the units that you give PlanOut matters when you're passing in a list of units. So in these 2 cases, the random assignments are different even though they're both using user URL pairs. So it matters if it's a user URL pair versus a URL user pair. And then we'll talk a little bit more about how this fits into the management infrastructure. Does anybody have any questions about random assignment?
I don't want to derail anything, but is there a 10-second answer to turning off the login in the notebook when I'm running this?
Oh yeah, I have no idea.
Okay, fair enough.
And
that's fine.
if,
Thanks.
If there are people who are like really competent IPython users, it'd be great if somebody could figure this out. I think that like 3 or 4 out of 5, 3 out of 4 or 4 out of 5 people who have tried this don't have any issues, but I think there are some IPython installations where things are kind of borked. Okay, now on to logging. Oh, one question back there.
So let's say you're using a uniform distribution, and rather than putting in 0 and 1 as my options, do those need to be unique? Can I put 0, 0, 0, 1, and does that get grouped together, or can I use that as kind of a poor
Yeah,
man's
you can
weighting,
do
or
0, 0, 1, and that
does
would
it treat
assign.
those as distinct categories or not?
Those are going to be logged in the exact same way.
Okay.
Because if you think about the way that this is being integrated on the front end or whatever system is hooking into it, they're just requesting parameters from the experiment. And so PlanOut has no concept of group. There is no control group versus treatment group or an A versus a B. It's just the parameter. One ghetto way of implementing a weighted choice would be to just insert the same variable multiple times in the list.
You could talk about what data you're collecting from the experiment?
Yeah, we'll talk about. I think that'll be a little clearer once we get to logging. Okay. So if folks want to open up their terminals and go to this PyData tutorial directory, they're going to find a bunch of log files that have gotten pooped out automatically. And what we're going to do is we're going to execute this logged experiment. And we're going to look at some of the log data that's produced by this. So by default, it uses the experiment name. It uses the logger module to output files to .log files with the same name as the experiment. So in this case, the experiment is logger experiment. So we're just going to tail-f it. So this will give us the results as they come in. Actually, why don't I clear my terminal? Wow, what is that? So here we have an experiment that's kind of similar to the Facebook Composer, where people can post status updates. And in this experiment, we've got some parameter x, which is either what's on your mind or say something, and that's assigned with uniform probability. And then we have this other function that's essentially, or operator that's essentially a coin flip. And it's going to produce data and pump it out to this log file. And so each time you get an assignment for this particular, there we go, for a particular unit, it's going to log it, right? So each time I do this, there's going to be a log. Now, if I were to just run this, say we have a different user ID, and we're not requesting any parameters, no log is produced. So this is called exposure logging, and it happens automatically. And so the idea is that an individual is exposed to a treatment once you request a parameter that could possibly affect their user experience. So if you're just saying, like, get me an instance of this class, and you're not doing anything with it, then there's no reason to say that that user was exposed to the treatment. And by only considering users who are actually exposed to a treatment, you can substantially increase the statistical power of your experiment. And you can see that when we do this random assignment, and we request get multiple times, it doesn't produce any additional logs. And that's because the way we've set up simple experiment was that it only does an exposure log once per instance of the class. And in a production system, what you would do is probably implement something that checks a memcache key to see if you've exposure logged that particular input for that experiment. And if you have, you don't need to log that data again because you know the user has been exposed already. You can also do manual exposure logging. So here we have a log exposure method, and then you can optionally put in additional data. So here we're recording the endpoints that produce the content. Or it didn't actually, yeah, the endpoint for which we're showing the status update. You can also have event logging. So let's say they actually post a status update. We can log the event, posted status update, and we can log some kind of metadata, like that it was a photo. And so there are two ways to think about the logging. Here's kind of a simplified picture of how our experiment analysis pipeline works. Is we have exposure log data that's joined against some metrics that are automatically collected. So let's say how often a user has logged in the past however many days, or how many pieces of content they've produced in the past however many days. And that's joined on the exposure log. And then there's also an event log, which might be some particular conversion instance. So let's say that I'm running an experiment that has to do with I don't know, getting users new friends. We might log this particular event, and that would be in the event log. Or we can just join all of our exposure logs against this kind of routinely collected data. And then that gets processed in some way. We do some automatic analysis, and that's available via graphical interfaces. And so let's put all of this together via a sample web application. How am I doing on time? OK, cool. So we've got the sample web application, and let's say it's an experiment that runs for a music store. And so users can view particular albums, and they can listen to songs. And we're trying to test what would happen if we were to sort songs within the album by rating instead of track number. So this is our hypothetical experiment. And this is the code. We're just assigning this one binary variable, which is sort by rating. And that's going to be 1 with a 20% chance. And that's being hashed on user album ID pairs. Right, and by hashing it on the pairs, we don't necessarily we won't necessarily affect particular albums differentially, and we can also get greater precision because this is a within subjects design. Now we're also going to define this method called getPrice, which is how much the album costs. Let's just say all albums are $1.99, and now we have some kind of rendering web page. So this is something that exists on your front-end service that renders the page. And what we do is we retrieve the experimental assignment for the user album ID pair. And then we log the exposure with a price. Oftentimes, it's not even necessary to call log exposure. We get the parameter we might do something that affects how the content is rendered, and then we would generate the HTML and render the template, for example. So that's the render web page code. Then after users are presented with this interface, they could potentially purchase an item. And so we might have some code that handles a purchase. And in this case, we'll get the experimental assignment, log the outcome, and then do whatever else, like let's say download the album onto the user's computer. So this is the handler. Now what we're going to do as part of this simulation is write this function that's simulate user decision. And what we're doing here is just using PlanOut to get the hypothetical experience of the user. So this is not something that would exist in your hypothetical code, although it might exist if you're an analyst and you're trying to do a power analysis for your experiment.
Sorry, I might have missed it, but did you mention, do you do multinomial tests on the back end of this? Like, how do you actually compute the significance of your results?
How does Facebook compute confidence intervals?
How does PlanOut? It just reports the counts, that's all it does?
PlanOut doesn't do any aggregation. It just logs raw data, and that's up to your kind of data analysis infrastructure to either fit whatever regression model or do the bootstrap confidence intervals. Typically, we use a lot of bootstrap confidence intervals at Facebook for evaluating the results of our experiments. So yeah, this simulates user behavior, and what we're doing here is turning off exposure logging because this isn't really like a legit part of the experiment flow. And we're simulating this user decision, and the idea is that if they do not see the sorted version, then the probability of conversion is 0.1. And if they do see the sorted version, the probability of converting is 0.15. And so this is the generative model. So there's an absolute treatment effect that's a 0.15 increase in the likelihood of clicking on the purchase button. So then we run the simulation. This takes a little while. It's done. And so now we've recorded a bunch of log data. So now if we were to go to our terminal, we can see that there's this music experiment log, which is pretty large and has a bunch of entries. And so we can load up this data. Each line, as you might recall, is just this JSON encoded blob. So we just use json.loads for each line of the file. In a production setting, this might be writing your data to Scribe or a database. And so this is what each line looks like once it's loaded in. It's this kind of nested dictionary that shows the event type, whatever extra data, all of your input data, the name of your experiment, what parameters are being assigned, the salt that's being used in case you change the salt midway through, which is kind of dangerous, and a timestamp. Usually we want to deal with data in a tabular format, so we can flatten this. I stole this piece of code from Stack Overflow. And so we can take this kind of nested data and generate a flat table. So this is what the table looks like, the tablified data frame version. So we have this table, and then what we do is we extract all of the exposures. So that's what this line does. And then we uniquify it, right? So we have just a single row per user album pair, and that user album pair should always be assigned to the same rating. So then now if we want to know how many individual pairs were assigned to each condition, this would be the crosstab for that. So you could see that it's about 8:2, which is almost exactly the proportion that we specified earlier on. It's a probability of assignment to the treatment with probability of 0.2. And then we can extract the conversion data. So here we extract the purchase events. Then we do a left outer join on the unique exposures. One thing that's a little funky about pandas that I've learned is that price, or that missing entries are nan. So that's what this means, is we don't have a price for these guys because of the right outer join. So then we have this Boolean value that's whether or not the user had purchased for that particular exposure and how much money we got. And then we could just do roll-ups of that. So let's say compute the mean purchase rate and the mean revenue. And this purchase rate is exactly what we set up in our generative model. And you might do something similar to this in order to do power analysis, although personally I use R for my power analysis. Any questions on logging?
Power analysis a general term or a specific? Does power analysis refer to some specific thing or just?
Just like power calculations.
Okay,
so,
just throwing it out. It's not capital uppercase power.
Yeah, just power calculations. Oftentimes, I guess I say power analysis because I often use simulations because it's not just a binomially distributed data, and so we might want to use some real outcome data that has a certain distribution, and then we might have some covariates which we know are correlated with the outcome, and so we might fit a regression model to the real data and kind of work with some augmented data set. So yeah, I mean, you could potentially do really complicated things and potentially use PlanOut to log data and not do any treatment assignment. So that's another approach that you could use for the kind of planning stage of your experiment.
Yeah, earlier you used like a uniform variable and just set uniform choice instead of the 8:2, and here you're using a binomial instead of 0.2. Any difference?
You're saying weighted choice versus binomial?
Yeah.
Yeah, I mean, if it's a 0-1 variable, then there's no difference. If it's like a 2-element list, but weighted choice could include any number of choices. It could be a vector of length 30. So the next thing I'm going to talk about is the PlanOut interpreter. So at Facebook, when we use PlanOut, it runs under a PHP interpreter, and we'll often specify our experiments using this domain-specific language, which looks a lot like JavaScript, and is very similar to the PlanOut code that you would write in pure Python, except the operators start with a lowercase. And here's an example of a 2x2 factorial experiment. We can compile our code by running this planout.js compiler that you can find in this compiler directory. I'm going to run the compiler from IPython, so that kind of makes stuff a little easier. And so here's our PlanOut code, and we can run this compile function, and we do this. Note that to actually execute this on your machine, you have to have Node installed. So once we compile this PlanOut code, we get this serialized JSON. And now we have this string object that represents our experiment. which can be analyzed in various ways automatically by the software that's doing your data analysis, or summarized to analysts in certain ways. And this is actually the code that gets executed by the PlanOut interpreter. And the way that we use the interpreter object in PlanOut is by calling interpreter on the serialized PlanOut code with some particular salt, which will be abstracted away as the experimental level salt in a little bit, and then a dictionary that gets loaded up with all the input data. So anything that you load up into this dictionary exists in the PlanOut execution environment and can be used as variables over here. So in this experiment, we're doing a uniform choice of the button text, which is purchase or buy, and then we give users a discount with a 30% probability. And so we can see that we can run this serialized PlanOut experiment definition and produce different random assignments. Now, this code acts just like pure Python experiments. It uses the same hashing procedures. So let's say that we define this doppelganger simple experiment class, and we set the salt to be the same as this salt here. And we use the exact same variable names, button text and has discount, and the same units. Then the assignments we get are going to be completely identical, because it's really using the same objects underneath. We can also fit in this interpreter class into simple experiment. So we can extend the simple experiment class and override the assign method to use interpreter and run the interpreter and then basically do a batch update of the params. Another feature that I recommend using is this checksum. So PlanOut will automatically log a checksum of your experiment definition, so that if somebody changes your experiment definition midway through, which generally shouldn't happen, the analyst will be aware of that. And so now with this, we can just derive from this class, set the salt, and then set the script to be the serialized version, and it runs the experiment. And so now if we look at the log data, we can see that it's logged our experiment. It logs the salt correctly, and we have this checksum. And if we were to just change our code in some way, like let's say instead of buy as buy exclamation point, and we were to look at this log, now the checksum would change because the experiment definition has changed. So there are also other ways. Does anybody have any questions at this point?
This might be beyond the scope of it, but I can see changing your experiment and wanting to track that. But I guess there's also the issue that maybe some, you think you're running the same experiment, but the underlying code base has changed. Is that just a completely different set of tests you have to do?
Yeah, I mean, it's just really hairy when that happens, and hopefully there'll be like some announcement that a large aspect of your site is changing. But if that change is really substantial, it should be hopefully obvious from your data. But yeah, obviously, like, you can't have the PlanOut code or logging be aware of every other change that happens to your site.
When I was following along, it looked like the first in each group of 5 log statements had a different checksum from the other 4.
Yeah, I think that's because I had been messing with the definition at various points.
Even if I run it again, right? Oh, sorry. I mean, even if I put some spaces in the log and run it again right now without changing anything, it still looks like user 0 gets a different checksum.
Yeah, I'm not really sure why that would occur. We could chat about it later. So we can also generate PlanOut scripts. Oh, is there one more question? Yep.
Yeah, so my question is, if we want to use PlanOut in other language, we just need to use that language to implement this interpreter.
Yep. Yeah,
That's how
exactly.
we do it.
Yeah. And it's pretty easy to port the interpreter. If you look at the code, the interpreter itself is super short. Yeah. So the serialized code could also be generated algorithmically. So let's say that you have a user interface on the front end that generates dictionaries that look like the name of the factor whose keys are lists of the factor levels. We can generate these scripts using a function like this. And so you could just add additional key value pairs and it generates the experiment definition. So this is another advantage of using this crazy experiment serialization, is that you can allow people to create experiments without actually having to code anything. And then if you wanted to use this, you could write little things to generate these scripts. So all of this will work with the PlanOut framework. So here we're calling the experiment my generated experiment. Let's say that we change the experiment name just to my generated. We would see that it produced different experiments with different log files. So that's how the PlanOut interpreter works. So the next thing we're going to talk about is managing experiments. And so to do this, we have this concept of a namespace. And the idea behind a namespace is that it's a parameter value store. And so you request values for parameters, and you have some backend system that says, OK, what is the value of this parameter? And that might be some constant that's floating around somewhere, or it might be something that's determined by an experiment. And so this namespace manager takes care of that and says, OK, I have user ID 20. I'm requesting, let's say, the button color. We're going to take that input user ID. We're going to hash it to a certain segment number. Segment numbers are associated with experiments. And then it says, aha, user ID 20 is mapped to experiment number 2. And then we're going to run the PlanOut script for experiment number 2. And if the input unit belongs to an experiment, we do the logging and we return the values. If it doesn't belong to an experiment, we don't necessarily do any logging because the user isn't actually an experiment. And one thing to note about the way this system works is we're not mapping whole segments, which do not change over time, to particular experimental groups. And this reduces carryover effects. So this is called local hashing, if you're familiar with any of the papers on online experimentation. So how do namespaces work in practice? Here's an example of kind of one timeline for an experiment that we launched, where we had week 1, and we launched an initial PlanOut script to a small number of segments of users. Actually, in this case, they were advertisers. And we ran the experiment for a short period of time to make sure nothing was totally borked. And it seemed like our revenue was OK. And so we increased the size of the experiment. And in week 2, we launched this new experiment with even more segments. Then we decided some of these conditions don't really work well. It doesn't really tell us information about trade-offs that we're trying to explore with the experiment. So we changed the number of experimental conditions, added a few more conditions. And so now this is an entirely different PlanOut script. And then we launched it to many users and analyzed that over a long period of time, and then eventually made a launch decision. Mm-hmm.
What do you mean by segments?
Yeah, a segment is just a partitioning of the primary. So the question was, what do I mean by segments? A segment is just a partitioning of the primary units. So if you're primarily experimenting with users, users would belong to segments. And so you have some number of segments, let's say 10,000, and each of those segments is randomly assigned to an experiment. And once that's assigned to the experiment, there's additional random assignment that occurs within that experiment. So once we go through the code example, hopefully it'll be a little bit clearer how this works. I know it's a little abstract. So we have this class called simple namespace that we'll be using, and then also another class called default experiment, which is a lot like simple experiment, but it doesn't do any logging, and also has some functionality for just storing dictionaries of values. So in general, namespaces represent a set of related parameters, so things that have to do with all of them are like the ranking model for search, or all of them have to do with the display of product results in your search feed, or have to do with things that relate to pricing of certain goods. And all of those experiments are necessarily mutually exclusive. So you don't have to use a namespace to manage experiments that aren't actually modifying the same variable that's used in your code, right? In general, you should never modify an already running experiment. You should instead launch new experiments through namespaces, and experiments should be analyzed separately unless you really know what you're doing and are using statistical procedures that are designed to pool across related experiments. So let's say that we had multiple versions of an experiment. In this case, we have an experiment that has to do with a banner that is at the top of the user screen. And the first experiment, it says, hello there, or welcome. Second version, it says hello there, or welcome with different probabilities. So same parameters, different assignment probabilities. Third version, it says completely different things. So these are 3 versions of an experiment. They're all setting the same related parameter, which is the banner. And then we have this concept of a default experiment. So if the user doesn't belong to any experiment, what is the parameter that we're going to return if it's requested? So in this case, it's just a generic greetings is the text. Now here's how we define namespaces with button namespace. This simple namespace is really just a code example that I'm providing for people to understand how namespaces work. In general, you would set up namespaces through some kind of graphical user interface that's available to engineers on your website and stored via a database. So for this particular class, what we have to do is specify the name of your namespace, which gets used to salt your hashing procedures. You have to specify a primary unit. So this is the unit that gets used to assign inputs to segments. So you could potentially have an experiment in a namespace that operates off of user segment pairs, but it would partition it initially by the user ID. And then you specify some number of segments. So for the demonstration version, I'm saying 100. In a production environment, you would want to use something like 10,000 segments or 100,000 segments. And then when users are setting up the experiments, they shouldn't really be aware of the fact that like users or experiments are allocated in terms of segment numbers, but in terms of percentages. And then you can specify a default experiment class. So if a user or an input does not belong to an experiment, this value is instead returned. And then there's this kind of stub function, which kind of simulates what would happen if we were to add or remove experiments from the namespace. Again, this is something that would be done via a database or a graphical user interface in a production environment. So what we're saying here is that we've got 3 different experiments. The first 2 experiments use the same PlanOut script or assignment procedure. And the first one has 30 segments, the second one has 10 segments, and the last one has 40 segments. And they all have different experiment names. So if we try this out with a few users, here we see hello there, generic greetings, etc. We could run this for a bunch of input units. And you can see that these are clearly, in some cases, coming from the default experiment. In other cases, they're coming from V1, and in other cases, they're coming from V2. And so what's going on underneath the hood? Well, we're giving it, let's say we give it user ID 2. User ID 2 belongs to segment number 29. And if we look at the segment allocations, we can see how each segment number is mapped to a particular experiment name. And here you see that 29 doesn't exist here. So this particular segment will not be assigned to an experiment and instead uses the default value store. And so when we do this, this is going to return null. And so we see that the individual unit is not allocated to the experiment. So if we were to try this with a different user ID, sometimes it'll, I guess most segments are not actually allocated to conditions. But we can see that the number of segments that we have, or experiments that are running, do correspond to the number of segments that were initially allocated. OK. Well, that concludes the tutorial for the most part. Again, I would highly suggest using namespaces if you're running multiple experiments and to centrally manage your experiments. And to analyze your experiments with care if you want to somehow pool across experiments or run follow-on experiments. So just to recap, I believe that experiments are really useful for knowledge building. They're not just useful for doing A/B tests to optimize your site. There's a lot you can learn about your users and your products through running more sophisticated experiments. And that this PlanOut system that we've developed supports good experimentation practices and focuses people on parameters and makes it easy to do more complex things rather than baking off 2 alternatives. And if you use our system or adopt some of the ideas from our system, it'll prevent you from shooting yourself in the foot. And I should thank, you can download it. I guess hopefully a lot of you have done that already. My collaborators on this project are Dean Eccles and Michael Bernstein. And I'd also like to thank a number of engineers who worked on the experimentation system that a lot of the system is modeled off of.